Hello 30-1. This is part 2 of operations with functions, and in this particular section they're investigating the products of two functions. So this is something whenever our workbook is talking about investigations, this is something where I want you to do your best to follow through and investigate the math behind this on your own rather than follow the screencast and copy it down. But as you do your investigation, if you run into hiccups, come to the screencast and see whether you're headed in the right direction. All right. So I want you to investigate this particular thing, the product of two functions, follow the investigation, answer the questions, and as you need to, come back to the screencast to check and see how you're doing. Have fun investigating. So hopefully, as you made sense of that your table of values for f times g of x, you simply said, well, I know what that means. That means I should take the two y values and simply, because it's f times g of x, take those two y values and multiply them together. So that would be positive 30. And this would be 15, and that would be 4, and this would be minus 3, minus 6, minus 5, 7, and 9. And now we've completed the table, and we go and we plot those points on the graph at the side. So if you plotted those points, you might have noticed that, well, you're not really on the line of symmetry, but it sort of seems like if you connect them, it's some sort of a parabolic function. So as I come through and try and connect these points together, it seems like I make some sort of a parabolic function like that. And the vertex isn't exactly where it's at, but we've plotted it. We complete the table above, plot the points, and fit the grid and complete the sketch for all real numbers. So I should have arrows at the top, which I do. The functions f of g are those, so write a simplified expression. Well, when we do that, we say, well, f times g at x is simply algebraically 2x plus 1 times x minus 3. And if we simplify that, we clearly get 2x squared minus 6x plus 1x, that's minus 5x minus 3. And we definitely know that that is a parabola with a y-intercept of minus 3, and for math 20 we would have to complete the square and so on. So it says use a graphing calculator to graph the function of f g of x from part C and compare it with the graph from part B, and we'll see that that should be the same. Determine the domain and range of f times g of x. So you're going to have to use the max or min function of your calculator and find that minimum value. When you find the exact, and I want you to do your best to find the exact. Now, another way to do that is to complete the square from math 20. So I can use my graphing calculator. If I want to find the exact value, I could complete the square, or in math 20 we also had the vertex formula. And that's just reminding you of the things or the ways that we've done this before. Okay, so I want you to go and find that. So I'm going to choose to do it the mathematical way. I'm going to find that vertex so I can state the domain by factoring out minus 2. So I factor out a minus 2, and that leaves me with x squared minus 5 over 2x. I divide by 2 and square, so that would be plus 25 over 16 and minus 25 over 16. And we still have a plus, a minus 3 on the outside. And when I simplify this, I end up with y equals minus 2 times bracket x minus 5 over 4 squared minus 50, minus, well, it could be 50, but we don't want to write like that. Minus, when you kick this number out, when you kick that number out, you have a minus, positive, hold the phone here. We factored out a positive 2, silly. We factored out a positive 2, so it's minus 5 over 2. So when we kick it out, we get a minus 25 over 8 minus 3, which when you add those two fractions together is x minus 5 over 4 squared minus 49 over 8. So the vertex of this parabola, the vertex of this parabola happens at, sorry, that's a positive. I keep putting a negative there. The vertex of this parabola is at 5/4 and at minus 49/8. And that's the exact value of it. So when you go back, and I know you could do that on your calculator, but you will get a decimal and you have to convert that. So when it says determine the domain and range, go back to here, and what's a domain? Well, clearly it's a parabola. So the domain is x such that x is an element of reals. But because you now know the vertex, the range is now y such that y is greater than or equal to minus 49/8, and y is an element of reals. And now we can calculate f times g at 8 in two different ways. So one way would be to plug it into the function f times g at 8, and that would just be to plug it into the function. So that you go 2 times 8 squared minus 5 times 8 minus 3, and clearly that would end up being equal to 85. Or if you wanted to, you could find f at 8 and g at 8 in your original functions. And if you go back to your original functions, f at 8 in those simple little graphing equations, f at 8 turned out to be 17. And when you plug into g at 8 into that simple equation, again, just so you know where I'm coming from, if you plug in 8 right there, you get 5. And so f at 8 times g at 8 is equal to 85 either way. In this investigation, the product of two functions whose graphs are straight lines is a quadratic function. Can you find two functions whose graphs are straight lines where this doesn't cause a quadratic function? So can you think of two linear functions that when you take their product does not create a quadratic? So one example would be, even though it's a straight line, it's kind of trivial. If you had f at x was just equal to 5, it's just a constant function, and then you had g at x was maybe any other line, it could be x plus 3 or something like that. When you take the product of those two things, f times g at x, you simply end up with 5 times x plus 3, which doesn't cause a quadratic, it just causes a linear function that is different but not a quadratic. So in this one, just kind of reviewing the last two lessons, what is f minus g at x? Well, that's just simply subtracting the two functions. So that would be 3 square root minus 2, 3 square root x minus 2, and subtract the function g at x. And you just have to make sure you include the brackets, otherwise we make little distributive property errors. So that means you've got 3 root x minus 2 minus root x and plus 5, and that gives us 2 root x's and positive 3. When you look at f times g at x, well, that would be equal to 3 root x minus 2 times root x minus 5. And don't forget that these are binomials, so that's going to be 3x minus 15 root x minus 2 root x and positive 10, which when we collect our like terms is 3x minus 17 root x plus 10. And now if we evaluate f minus g at 16, well, f minus g at 16 is simply equal to 2 square root 16 plus 3, which is obviously 8 plus 3, which is 11. And f times g at 49, I can just put the equals right there, is simply 3 times 49 minus 17 times, I'll do that as 7, plus 10, which simplifies to be 38. Well done. You are done lesson 3, and go and give that assignment a try.